today we are going to look at how to write equations of lines. Today is kind of the backwards of yesterday. So yesterday we were given equations and we created graphs. Today we're going to be given either graphs or information, and we want to create the equations. So our key to this whole lesson is going to be that slope-intercept form that we learned yesterday, y equals mx plus b, where m is our slope and b is our intercept. So when we're given a graph, what we can do is find our intercept. So what's the y-intercept here? -1. So that's our b value. Then what you want to do is find 2 points on the graph that cleanly cross in a corner of a grid. So this would be one of them, that's good, and then another one would be up here. Okay? So find 2 points that cleanly cross in the corner of a grid, and then count out the slope between those. So rise over run is up 3 over 2, so our slope would be 3 over 2. So our equation then would be y equals 3 over 2x minus 1, or plus a -1. Okay. Questions? So pick out your y-intercept from the graph, that's your b value, then find 2 points that cleanly cross in corners of the grid and count up. Okay? Try this one. Okay, so our intercept is -2. And then we want to look for cleanly crossing points. That's one of them. We have another one here, and we actually have another one here. And it doesn't matter which ones you pick. Okay, we just need 2 points, and no matter what, our slope should be consistent. So if I pick 2 points that are close to each other and I find the rise over the run, I get 2 over 1. Our slope's 2 over 1 or 2. If you happen to not notice that first one and you pick the next one, you would have a 4 over 2 slope, which reduces to exactly the same thing. So it doesn't matter which 2 points you pick, as long as you're just picking 2 points that cleanly cross in the grid. You can pick any of them and then just reduce them down, and they should all be the same thing. So our equation here would then be y equals 2x minus 2. Questions? Okay, so then for the rest of them, we're going to be given different pieces of information. The key for all of them is going to be y equals mx plus b. If you look in the book, at some point, they're going to show you a different form of an equation called a point-slope form, which totally works, and if you're interested in that, you can look at that, and you can use that. For me, it's just another thing to memorize. So it works. Sometimes it's shorter, but if you're like me and you're not good at just memorizing facts, then it would just be another thing to add to your list of stuff to memorize. So I always use y equals mx plus b no matter what information I'm given. But if you look at any of their examples in the book, you might notice them doing something else. So our information here, we're given a slope of -1/2. That's an m value. We are not told what our intercept is, so we don't know our b value, but we are given a point. And a point always represents an x and a y. So if we plug in what we know y is 3, we know m is -1/2, we know x is 2, and we don't know what b is, but that's the only thing left, so we can solve for it and find it. So -1/2 times 2 is -1, and adding 1 to both sides gives a b value of 4. So then I can use the b value and the m value to write my final answer of y equals -1/2x plus 4. Your final answer should always have an x and a y in it, that's part of a linear equation, and no other letters in it. So b needs to be whatever number we find for b, and m needs to be whatever number is representing the slope. Okay? X and y should be there, and no other letters in our final answer
You
always.
don't use the numbers, you don't do 3 equals.
Right, so we use the 3 and the 2 to find the b value, but then we don't want them in our final answer because that's one point that's on this line, but we want the equation that represents the whole line, not just a specific point. Okay. Any other questions on this process?
Why is there always an x in this, like, in all the equations?
We just use the letter x to represent our independent variable. So I don't know why they use the letter x, but we could have an equation that doesn't have an x, just a y equals a number, and that would just be a flat horizontal line. But having that x in there is what allows it to have a slope. Okay, this one has the same type of given information, a point and a slope, so go ahead and plug those in and solve for your final equation. Okay, so we're given 2/3 as a slope. That is represented by the letter m. We're given a point, which gives us a specific x and y value. And we can take that information and plug it into y equals mx plus b. So y is 4, m is 2/3, x is -3, and we don't know what b is, but that's the only thing that's left, so we can solve for it. 2/3 times -3 is -2. Add 2 to both sides. Gives us a b value of 6. So then I'm going to take that b value and the m value and make an equation with them. Y equals 2/3 x plus 6. And final answer should have the m and the b in place, and then x and y should be variables. Questions? Okay, this is actually really 2 different questions based on some of the same information, but a part A and a part B that are individual of each other. So we're asked to write an equation of a line again. First through this point, which gives us an x and a y. And then we want to do 2 different things. We want to make our line perpendicular to and then parallel to a given line. We learned the other day about perpendiculars and parallels. What did we learn is true about the slopes of perpendicular lines? It could be a horizontal and vertical, but in general, there's 2 things that have to happen to slopes. They intersect at a right angle. Slopes, though, are what? Opposite and reciprocal. Okay, 2 facts about perpendicular slopes. They're opposite, so we get a positive, negative, and reciprocal, so they're flipped over. What did we learn about parallel slopes? They don't intersect as lines, which means that what's true about their slopes? They have to be exactly the same, because they have to be rising and running at the same rate, otherwise they would run into each other at some point. Okay, so in this line, there's a slope. The slope here is -3. So for part A, if I want to be perpendicular to this, I need to use a perpendicular slope to -3. Perpendicular makes 2 changes to the slope. It makes it the opposite, so positive, negative, and it flips it over. So what slope do I want to use?
Positive 1/3.
Positive 1/3. Okay, positive, negative change. So since the given one's negative, we want a positive. And then a reciprocal. So flip over 3 and it makes 1/3. So we're going to use a slope of 1/3 and the given x and y and do what we did in the last problem. So y equals mx plus b is our equation. Plug in a 2, plug in a 1/3, plug in a 3, and we'll want to solve for b. So we get 1 plus b. Subtracting 1 gives 1. And for part A, our answer is the slope we used and the b value we found. Questions on part A? For part B, we want to be parallel to that line. And we said parallel slopes are exactly the same. So we're going to use a slope of -3 for part B. So it's exactly the same as the given line. We're still going to use the same point to go through. So y equals mx plus b. Our y is 2. Our m is -3. Our x is +3. We solve for b. Multiplying gives -9. Add that to both sides gives 11. So then we write our equation, y equals the slope we used and the b we found. So if we look at that equation and the original one we're given, we can see they have the same slopes. They're going to be running next to each other, but one of them's hitting at 2 and the other one's hitting at 11. So they're not exactly the same line, but they'll be running along next to each other. Okay. Process of finding the equation, same as the last problem, plugging in what we know, but new on this one was thinking about what parallel means and what perpendicular means, which we learned about a couple days ago. Questions? Okay, try this problem, which is the same in that it has the same 2 parts. Okay, so we are given a point which gives us an x and a y. For part A, we want to be perpendicular, part B parallel, and we're given a line with a slope of 2. So for part A, where I want to be perpendicular, what slope should I use? What's going to be perpendicular to 2? -1/2. We need the opposite, so one should be positive, one should be negative, and we need a reciprocal, so we need to flip that over. So then I'm going to use in y equals mx plus b, a y of -3, an m of -1/2, and an x of 2 to find b. Multiplying there gives -1. And adding 1 to both sides would give -2. So our answer is the equation with the m that we used and the b that we found. Questions on part A? Part B, we want to be parallel. Parallel slopes are exactly the same. So I'm going to use a slope of 2 so that it matches the given line. Plug into y equals mx plus b, a y of -3, m of 2, x of 2, and find b. Multiplying gives 4. Subtracting out gives -7. And we plug in the m that we used and the b that we found. And we can see that this is like the original equation, but it has a different y-intercept. It's going to hit at different points, but run along side by side. Questions? Okay, so we've been given some different information. We didn't do any where you were just given your slope and your intercept, but you could be, and then you would just throw them right in. Throw in the m, throw in the b, and you're done with that, okay? So it's kind of the easiest ones. We didn't do any examples of that. We did ones where you were given a slope and a point, okay? Then the last thing we can be given is 2 points, no slope at all. So if we're thinking about our equation of y equals mx plus b, we don't know either thing that we need for our final answer. We don't know m, and we don't know b. Our first step is to find m. Finding m is finding slope, and in lesson 2.2, that's what you did for every single problem, was find slope between 2 points. How do I find the slope between 2 points? y2 minus y1, or x2 minus x1. It doesn't matter which point is your point 2 and your point 1. I usually just do the later one minus the earlier one, in the problem, but it doesn't really matter. Be careful with double negatives. Okay? So I'm doing the y subtracted over the x's subtracted. That gives me 5 over 5, which is 1. So now I know my slope. I have 2 points. You can select either point to be your x and y. It doesn't matter which one. I don't like negatives because I usually lose them. They're just little and they get lost along the way. So I'm going to choose to use the second point. But you should get exactly the same answer if you choose to use the first point. So now we have a slope and a point, and this is exactly like the first examples that we did. So we just had that one extra step at the beginning where we had to find our slope since we weren't given our slope. So we're going to use y equals mx plus b. I chose to use y as 4. We found m is 1, x is 3, and b. Don't mix and match though and say like, I'm going to use this x and this y. You have to use 1 point. So pick 1 point that you like better and use that as x and y. Don't take x from here and y from there. That's no good.
What happens if you do?
You'll get a wrong answer. So we multiply and get 3, subtract out that 3, and we get a b value of 1. So then we write our final equation as y equals, we found m was 1, and we found b was 1. You don't have to include that first one for the slope. 1x is the same thing as just x, so that's fine if you just write that. You do have to include that second one because adding one does make a difference. Questions? So find your slope by change in y, subtract y's over subtract x's. Then select one of your points to be your x and y and do it the way that we've done the other ones. So go ahead and try this one. Okay, so our first step is to find our slope. So to find slope, I subtract the y's, 2 minus 5, over subtract the x's, 4 minus 1. Doesn't matter what order you do the subtraction, just do it the same way both times. So you should end up seeing the points stacked on top of each other. The 2 and the 4 are together, the 5 and the 1 are together. Okay, so then when I do my subtraction, I get negative 3 over positive 3, or negative 1. Then select one point that you like better, it does not matter which one, to be your x and y. Then use your m that you just found, your x and your y, to plug into y equals mx plus b. So I chose to use the y as 5. We found m is negative 1. I need the x of 1, and I don't know the b value. I get negative 1 when I multiply, and 6 when I add. So my final answer then should be y equals negative 1x plus 6. And if you use the other point, the 4 and the 2, you should get exactly the same thing. Okay, assuming that you don't make any mistakes. Again, that 1 in front of the x isn't really necessary. The negative is though, but if you just said negative x plus b, that's exactly the same thing. Okay. Questions? The last set of questions on this direct variation is something we're actually just going to skip right over, which means that on your homework, you're just going to go to 40. Those of you who worked ahead may be a little bit angry with me on that, but I suppose you probably still already have it done. So, all right, so just go to 40 there, and we'll take out those last group of problems.